A cubed plus B cubed plus C cubed equal to 3ABC. ABC are integers, and they are from -3 to 3. So let's solve this problem. Because the problem is symmetric with respect to ABC, let's consider that. No, I wanted to say A less than or equal B less than or equal to C. Let's not consider that condition, and if we need it, we can use that. Okay, so we have a famous identity that A cubed plus B cubed plus C cubed minus 3ABC equal to A plus B plus C times A squared plus B squared plus C squared minus AB minus AC minus BC. Now, by assumption of the problem, A cubed plus B cubed plus C cubed equal to 3ABC, so it is equal to 0. Now, because it is equal to 0, we can conclude left the first part is 0 or second part is 0. If first part equal to 0, case 1, A plus B plus C equal to 0. Let's consider all cases. They are from -3 to +3. So we can say ABC. Without loss of generality here, we can consider that for this part, A is positive, and then we multiply by 2. Positive cases are only we need to take case 0. So let's consider if A is 3, because if you negate all A, B, C, again sum is 0. If A is 3, B plus C should be -3. Sure. So we can say 0, -3, -1, -2, -2, -1, -3, 0. It is this case. And for all of them, A is 3. And you should multiply this by 2, because if you negate all A, B, C, or let me write something else for you, the sign. You can say, for example, it is plus minus, then you can consider minus plus for this. Here you can consider plus, let me say plus, minus, minus, you can consider. Okay, here plus minus this, so it will be minus plus plus, and here plus minus plus plus, and plus minus plus 0. Okay, so in this case, A, B, C were, A was 3. If we consider A equal to 2, so some of them should be -2. So here we can say, if for example C is -3, and we have what, some of them will be -1, and it will be +1. And it is -2, and it is 2, so it is 0. So if it is -1, then we can say -1, 2, and then we can say -2, -3, 2, 2, 0. Last case is +1. Okay. Like previous case, you can consider all other signs. You negate all of them. Now, in next case, we consider A equal to 1, and you can calculate the number of answers. Here, if A is 1, if it is -3, it is 2, and if it is -2, it is 1, it is 1, it is -1, 0, then you can say, okay, we are adding this, you subtract this by 1, it's -1, 1, 1, -2, and then it is 1, 1, -3, it is 2. And last case, ABC, consider A is 0, so it will be -3, 3, -2, 2, -1, 1, and 0, 0. Next case is 0, -1, 1, -2, 2, -3, -3, 3. Okay. And for this one, A is 0, we don't have positive, negative, but for previous cases, for example, let me write only for one of them. Positive, negative, positive, negative, positive. It will be two cases for each case. It's positive. Okay, now let's consider it was first case. Let's consider second case. In second case, a squared plus b squared plus c squared minus ab minus ac minus bc equal to 0. Now, we multiply this by 2, both sides by 2. So we have 2a squared, 2b squared, 2c squared minus 2ab minus 2ac minus 2bc equal to 0. Why I multiplied both sides by 2? Because of this famous identity that x minus y squared equal to x squared minus 2xy plus y squared. Now, because of this identity, I rearrange these things. I say a squared minus 2ab plus b squared plus a squared minus 2ac plus c squared plus b squared minus 2bc plus c squared equal to 0. Now, if you apply this identity, the first part, a minus b squared. Next part, a minus c squared. And the last part is b minus c squared equal to 0. A, b, c are integers. They're perfect number. They're square numbers. So each of them at least 0. So we conclude a minus b is 0, a minus c is 0, and b minus c is 0. And then we can conclude what? We can conclude from first part, a equal to b. From second equation, a equal to c. And from third equation, b equal to c. And if we consider all of them, a equal to b equal to c. So they should be equal numbers. But in previous case, we should calculate the cases that we've not counted in previous case. If a equal b equal c, then all of them 0. So this answer, the only answer is common in both of them is this. So we don't count it again. So a equal to b equal c, it can be 3, it can be 2, it can be 1, it can be 0. No, because we've counted this -1, -2, and -3. So we found 1, 2, 3, 4, 5, 6 other answers for this problem. If you had questions, send message to my WhatsApp number and please don't forget to subscribe. Turn on the bell and like the video. Thanks. See you next time. Bye.